The name of the man to whom the system of Vedic mathematics came, after a good deal of solitary thought and contemplation, was Pujya Bharati Krishna Tirthaji. And what came to him were a set of sutras or sayings, and the one we've been using is vertically and crosswise, or in Sanskrit it's urdhva tiryagpyam. So we've seen how it can be used in division, and then I didn't expect that to be understood, and then we used it in multiplication. It was more obvious how it worked in that context. So now we're going to compare the method of long division that, well, it's hardly taught anymore in schools in this country, but is still used elsewhere, with his method. So we're going to divide 71 into 4, 5, 2, 3. In the long division method, we have to ask ourselves some questions. How many times does 71 go into 4? Doesn't. Into 45? Doesn't. Into 452? Well, clearly it does, because that's greater than 71. Then we have to say, well, how many times? And often with long division you find yourself writing out the times table of a number like 71 so that you can pick the correct multiple to subtract. Now in this case I think we can guess it's going to be 6 times 71 that we want, which will give us 426. 6 71s are 426, and we subtract that. And we know that 71 goes 6 times into this. Now when we subtract that number from this, we get left with 263. And the next question that we're going to be asking ourselves is, how many times does 71 go into 263? You can probably see that we're going to need 3 times 71 there. Now let's look at his method for dealing with this. We're dividing 71 into 4,523. And instead of asking ourselves, how many times does 71 go into 4, into 45 and 452, he just uses the tens digit and says, how many times does 7 go into 4? It doesn't. How many times does it go into 45? Well, it does. And it goes 6 times. 6 sevens are 42. And we subtract 42 from 45 in our heads, and we get a remainder of 3, which we carry into the tens column. Now, then, in his method, you say 6 times 1 is 6, and you subtract it from 32, which gives you the 26. Now just note where the 26 has turned up here. There it is. There's the 26. And then the next thing we're going to do is say 7 into 26 go 3 remainder 5. And if we do 71 into 263, we will also have 3, and we will proceed like that. So this method gives you the same number which has to be divided, 26 in both cases, but this produces it in a much more intelligent and efficient manner. And I think this method that he produced can very well be said to be the most intelligent and best piece of arithmetic that's been seen in the Western world since Fibonacci introduced the Arabic, actually Hindu numerals, in the 13th century. So it's a significant achievement, this method of his.